Hello again. This is Ife Martins of Kini Big Deal, and we're still on the matter of indices. Now, if you remember in the previous video, we started this whole idea of laws of indices. As much as you may like to do illegal things, you don't like anything law, or you think laws of indices mean the constitution of a country beside India or whatever you want to call it, provings of indices. Anyway, the best way to think about it is just see them as how to handle indices. Okay, a very quick recap. Remember, I told you any number raised to power 0 is always 1. Then a raised to power m times a raised to power n equals a raised to power m plus n. It means just copy out the base and add the indices. Now we want to do something. We want to introduce another law. Okay, we call that one law C. Okay, it says a raised to power m divided by, do you remember this divided sign? Divided by a raised to power n equal to a raised to power m minus n. Okay, well, look at it very well. You should start seeing a relationship. In the case of our rule B, let's call it the yellow rule because it's yellow, like you can see here. We have a raised to power m times a raised to power n equals a raised to power m plus n. But here we are dividing. So what is happening? We are actually subtracting the indices. So let's have an example before we talk too much. If you have x, voila, don't start, x raised to power 6 divided by x raised to power 4. The answer is x raised to power 6 minus 4, which is equal to x raised to power 2 or x squared. Okay, x squared and x cubed. Okay, let's say x squared and x cubed. I tend to call them the celebrity indices. Okay, I mean, why not just say x raised to power 2, which is correct, but they have their own special name, x squared. X3 also has its own special name, sorry, x raised to power 3, which is x cubed. So let's call them celebrity indices. So let's have another example. If you have 8 raised to power 7 divided by 8 raised to power 3, okay, what do you have? You copy the base, okay, the same base that you're using, your base, which in this case is 8. Base is the one you are raising to a certain power. Okay, so you copy the 8 and have it as 8. 8 raised to power what? 7 minus 3. Okay, now, so you don't just think it's an abstract concept that is only possible by divine, whatever, whatever. Let's bring out that thing you don't like, that my trusted calculator, okay, and pretend we have all the time in the world. Let me cancel this. Again, we have 8 raised to power 7 divided by 8 raised to power 3. What is the answer? 4096. 4096. Okay, that's what we have. Now, if we evaluate the answer we have on the chalkboard, okay, the 8 raised to power 7 minus 3, which will give us 8 raised to power 4, because 7 minus 3 is 4. Note this number. Let's just innocently do 8 raised to power 4. Okay, 8 raised to power 4. 4096. I mean, what are we talking about? The calculator cannot be lying, please. Anyway, back to the matter. So, as you can see, you have 8 raised to power 7 minus 3, which is the same thing as 8 raised to power 4. Please, if you cannot subtract 3 from 7, just return the laptop or the tab to the person you borrowed it from, okay? Stop wasting their data. Now, let's take another example. If you have something like, say, simplify, let me write it for those that cannot spell simplify. Simplify an expression like 5 raised to power, sorry, 5 into y raised to power 9 divided by y raised to power 5, okay? Look at this expression very well. There's a guy called Five outside trying so hard not to mind his business. He wants to get involved with what is happening. But we are not going to involve him yet in what is going on, okay? Now, take a look at this expression and tell us, or I mean, tell yourself what you discover. What you will discover is that inside the bracket, there are two values there, okay? That is the y raised to power 9 and the y raised to power 5. So, of course, having both fives, you know the bases are the same, then it is correct for us to apply the laws of indices to them. Then how about the 5 outside? Well, the 5 outside is a constant that we're meant to multiply by everything, so we won't be bothered with that, okay? So how do we solve this? We solve it by saying, remember this our rule, okay? Remember our rule that says a raised to power m divided by a raised to power n equals a minus n. That's what you do. So you bring out this one, this whole stuff here, and say 5 into y raised to power 9 divided by y raised to power 5. This is equal to 5 into y raised to power. How do you do this? This, in this case, is like the a we've been talking about, okay? This is the a from our rules, okay? This 9 that we have here is the m, okay? This is also our a. The 5 we have here is our n. So the answer says a raised to power m minus n. So y raised to power, what is our m? 9 minus, what is our n? 5. So the answer is 5 raised to power, 5 into, sorry, I keep saying that, 5 into y raised to power 9 minus 5, 4. So the answer is, of course, when you just multiply 5 into bracket, anything means there's an invisible multiplication sign here, which people don't write so they don't appear like inexperienced mathematicians, okay? So the answer here is 5y to the fourth power, or 5y raised to power 4. Okay, in a separate video, we're going to practice a lot of these concepts. So let's quickly move to another rule that you may not like, but I mean, it's quite simple. Let's call it rule D. Okay, which color should I give that? I'm really feeling patriotic. Okay, so I will use this beautiful green. Okay, let's have it as our rule D. Okay, the green rule. The green rule says if you have a bracket like this, a raised to power m, then the whole expression itself is raised to power n. The rule says, don't worry yourself. You see this guy inside, the index inside and the index outside, just multiply them. Nobody should form a algebra for anybody. Okay? It means the base stays, then m n. Mn is a fancy way of writing m times n. So it means if you have a bowl or a nylon of bread, okay, bread raised to power oh bread raised to power butter, okay, then you have a cup of tea outside. All join now. You can eat bread and butter and also take it with tea. So if someone asks you, what you take chop your bread, you say na butter and tea. That's the same idea here. Okay, let's clean this off and have a few examples, okay, with our bread and butter illustration. Okay, I think this is good enough for our illustration. Let's not waste time. Okay, if you have an expression like okay, I'm still loving this green, so let's stick to it. If you have something like say 4, oh sorry about that, 4 squared or 4 is power 2. I'm saying squared because index 2 is a celebrity index, like I told you earlier on. Then everything here raised to power 3. Okay, now please, you need to pay strict attention here because ordinarily what's in the bracket is 4 squared. So that means 4 times 4, which is equal to 16. But we are not done. It's inside bracket. So it is this 16 itself that is now being cubed or being raised to power 3. Okay, now let me intimidate you with my wonderful computer again, my calculator that is. Um, Mr. Calculator, see what we are trying to do. We want to do 16 cubed, okay? 16 raised to power 3, okay? Now, note the figure, okay? That is 4096. Then you see what will happen when we try to do this now, okay? 4096, Mr. Calculator will be right back, okay? Then if we go according to our pen here, according to our rule, you have 4 raised to power 2 squared, everything now raised to power 3. So what you should do, according to here, what I told you earlier on is, you say 4 raised to power 2 times 3. Okay? The illustration said you are eating bread. Okay? You are eating bread with, excuse me, let me make that bigger. Okay, you're eating bread raised to power butter. You're eating your bread with butter. But despite having butter, somebody says you must upgrade the bread to tea. So I'll join now. Nothing spoil. Wait till you take chop your bread. I want a butter. And what? Butter and tea. So you are mixing the butter and the tea together and raising the bread to eat. Simple. I don't know if that makes sense to you, but that is the general idea. So going on, this now becomes 4 raised to power 2 times 3, 6. Now, if you remember the value the calculator gave us last, which is as a result of us expanding 4 times 4, 16, 16 raised to power 3, the manual way, once we do 4 raised to power 6 now, that is 4 raised to power 2 times 3, we should be able to get the same thing to know we are correct. So I'm going to cancel this out, okay? 4 raised to power 6 equals to 4096. Wonderful. Okay. So, well, the thing is, I'm not encouraging you to rely on calculators for your answer, but it is important for you to see how those rules work because these are the rules that programmers or whatever they put into computers. So, unlike what Uncle Sabinus told you, witches are not inside calculators, okay? It's mathematics and programming. We'll get to that another time. But once Uncle Sabinus tells you again that these Oyibo people they be witch, oh, just smile because if you antagonize him, so yeah, money if you no show. So moving on, what have we learned now? We've learned that a raised to power m, then everything into n means a raised to power m times n, which is aptly written as a raised to power mn. Okay, in the video dedicated to worked examples, we are going to take more of all these concepts so that you can actually have the idea burned into your head that when you wake up like this, laws of indices, you eat laws of indices, Gary, laws of indices, hey babe, laws of indices, my boo, laws of indices. Okay, these are the concepts you must know. Once you understand this concept, I assure you there is nothing stopping you. Okay, if you enjoyed this video, feel free to put your comments. Even if you didn't enjoy it, let's hear from you. The whole idea is to improve and serve you better. You can request for videos for us to explain other concepts to you, ask your questions, and we'll be glad to serve you. So in the next video, I'm going to talk about the remaining 2 rules. Then we'll start doing worked examples. This is Alagba Benjamin for Kini Big Deal. Thank you very much.